let's check this code within our script. So function display will take a parameter text, okay, and it's going to add to our demo div. Okay, so we have got two functions, first function, second function. Okay, so both are going to call this display function, and they will send different value of parameters. Okay, first function will send first and second function will send second. Here we are calling first function first followed by second function. So obviously first function is supposed to display first, which gets overwritten by second, right? See, second. But if we change the sequence of this function, that is the second function followed by calling of the first function. Okay, so in that case what will happen? Second gets displayed, which gets overwritten by first. Okay, so our final output will be first. See? So function sequence, JavaScript functions are executed in the sequence they are called. Okay, so not in the sequence they are defined. So it doesn't matter we have defined the first function first followed by the second function. It totally depends on the sequence in which we call the functions. Okay, so sequence control, sometimes we would like to have better control over when to execute a function. Okay, so that's what sequence control is all about. So here in this function we have written another function. Here we can see that this calculator function returned our result. It then sent this result as a parameter to the display function. Okay, or what can we do? We can call the calculator function, then let this function called display function within it. Okay, so instead of calling both the functions separately, we can call the second function within the first function. That is, we can call the display function within the calculator function. So inside the calculator function, you can see that instead of returning the sum, we are directly calling the display function and passing the sum as the parameter. Okay, so we can see it's giving the result 10. So problem with the first approach is two functions were required to be called to display the result, and problem with the second approach is that we are calling a single function, but we cannot prevent the calculator function from displaying the result. Okay, so here callback comes into the picture. It's a function passed as an argument to another function. Okay, so see, we have written the same calculator function, but here we have changed the number of parameters. Okay, instead of num1 and num2, we have also added my callback function. So instead of returning the sum, we are passing it as a parameter to our callback, and while calling our calculator function, we have changed the third argument. So we have placed our display function as the third argument, which is our callback function. That's giving us the same output 10. So in our example, display is the callback function. It is passed as an argument to calculator function. Okay, now we have to remember, so while passing a function as an argument, remember not to use parentheses. That's very important. So let's move on to our next example. Here we have taken an array of my numbers, which consists of both positive and negative numbers. Okay, and we have written a checknum function which returns a boolean value true if the number is positive, else if the number is negative it returns false. Okay, we are passing this checknum function as the callback parameter in our rem negative num function. Okay, which is then assigned to a constant pos numbers, which is positive numbers, of course. Okay, now within our remove negative number function, there are two parameters. We can see numbers and callback function. So we have here we have just executed a loop through this numbers, okay, where we are actually calling a callback function within our if condition. Okay, so if the number is positive, it gets returned, and that gets pushed into my array. Okay, and this my array is returned to our pos numbers constant. Okay, on line number 21. So let's see the output showing us all the 4 positive numbers from our my numbers array. See, my numbers array are having this numbers, and that's what is being displayed over here as an output. So functions running in parallel with other functions are asynchronous. For example, set timeout. Set timeout function. Within it we have written a my function and have given a delay of 3000 ms, that is 3 seconds. So our output is going to be displayed after 3-second gap. Okay, so let's check the output. See, hello world. Let's refresh and see. it's appearing after a gap of 3 seconds. Okay, see again. Okay, set interval in which we are passing our my function as the callback, and here the delay is of 1000 milliseconds, that is 1 second. We have created the date object and are going to display the time in terms of hours, minutes and seconds in our demo output. See, showing us the time. So note, there are two ways in which the callback may be called: synchronous and asynchronous. Synchronous callbacks are called immediately after the invocation of the outer function with no intervening asynchronous task, while asynchronous callbacks are called at some point later after an asynchronous operation has completed. So understanding whether the callback is synchronously or asynchronously called is particularly important when analyzing side effects. Now consider this following example where we are initializing a value equal 1. Inside the do something function we are changing the value to 2. We are using console.log to check the value. If do something calls the callback synchronously, then the last statement would log 2 because value equal to is synchronously executed. Otherwise, if the callback is asynchronous, the last statement would log 1 because value equal to is only executed after the console.log statement. So examples of synchronous callbacks include the callbacks passed to array prototype map, array.prototype.forEach, etc. Examples of asynchronous callbacks include the callbacks passed to setTimeout and promise.prototype.then. So what have we learned so far? JavaScript deals functions as first-class citizens, that is, function can be passed as an argument to another function as well as a function can be returned from another function. A callback in JavaScript is a function that is passed into another function as an argument. Callback has nothing to do with the asynchronous behavior of JavaScript. A callback is simply a function that is passed as an argument to another function and is intended to be executed at a later time or after a specific event occurs. This event doesn't have to be a synchronous operation. It could be a user action, a specific condition being met, or any other event you want to handle with a separate function. We have already seen the examples of callback in context of synchronous and asynchronous behavior. Let's explore more examples. So it's a callback synchronous example. So here we have written a perform operation function which is taking a callback as its parameter. Again, within it we are using console.log, performing the operation, and then we are calling a callback function. And our callback function is basically it's within it we are executing console.log callback has been executed. So we are calling our main function with a callback. Main function is the perform operation function. Okay, and within it we are passing callback function as the argument. Okay, so this is the output. See, performing the operation followed by callback has been executed. Now let's hop on to our next callback asynchronous example. Okay, here we have written our function do something async in which we are passing callback function as the parameter, and within it we have setTimeout function which gets executed after an interval of 1000 milliseconds, that is 1 second. So within this setTimeout function we have console.log async operation done followed by our callback function call, and within our callback function we have our console.log callback has been executed. So we are calling the main function with the callback function as its argument. Okay, now let's see the output. Async operation done, callback has been executed. As more nested callbacks are added, the code becomes harder to read, maintain and reason about. This can lead to bugs and difficulties in debugging. So let's see this one. Here we have declared functions. Function, async function is there where callback is passed as a parameter. We have put setTimeout inside it, in which there is console.log async function 1 done followed by calling of the callback function, and it's executed in a gap of 1 second. Okay. Similarly, function async function 2, so that was async function 1, this is async function 2, and similarly we have written async function 3. Okay, just the statements are different. Okay, so async function 1 done, async function 2 done, and async function 3 done. See, calling the code. Now we are calling the functions. So async function 1 followed by async function 2, followed by async function 3, and within there we have got our console.log all async functions completed. Okay, as you can see, pyramid of doom being formed. Okay, see, if there are more operations to be performed, then the pyramid's height will keep increasing, and so would be the impact of doom. Callback hell, also known as the pyramid of doom, is a situation in JavaScript where multiple asynchronous operations are handled using deeply nested callback functions. This creates a code structure that is difficult to read, understand, and maintain due to excessive indentation and the lack of a clear flow. Real world example. For example, an authenticated user performs some action from the browser which hits an API that involves getting the data from database and sending notification email back to the user. This could be performed in a series of steps, one after another. Number 1, receives request from the user. Number 2, authenticate the user. Number 3, check authorization level of user to perform an action. Number 4, perform the action. Number 5, send notification email. Number 6, send response back to the user browser. So it could be something like this. Here in the step 1, we are receiving the request from the user through the URL perform action, which is a post request. So in the event handler, request and respond are passed as a parameter. In step 2, we are authenticating the user. So this authenticate user, check authorization, perform action, all these are asynchronous calls. Okay. So in authenticate user, what we are doing? So the username and the password that we are getting from the request will be utilized for the authentication of the user. Okay. Okay, so if there is any auth error, then we are sending the response authentication failed. Else, if user is not authenticated, in that case, like when the is authenticated value is false, then we are sending user not authenticated. Okay. Else in step 3, what we are doing, we are checking for authorization level of our user. So means if the user is, if it clears the authentication phase, we are hopping on to our step 3, which is check authorization of user. So here in step 3, if the auth level error is there, then we are sending the response authorization check failed. So it basically means whether the user is allowed to access a particular functionality or not. Okay, so in that case, if this authorization check is failed, then we are sending this response. Okay, else if the authorized is false, in that case we are sending the response user not authorized. If it is authorized, if the user is authorized, then we are hopping on to our else block, which is our step number 4. So in step 4, in perform action, what we are doing, if the authorization level is also cleared, that means the user is authorized. In that case, if our action error is true, then we are if there is any error found, then we are sending the response action failed. Else what we are going to do, we'll hop on to step 5, which is send notification email. Okay, so here we are utilizing the username. Okay, and if there is an email error, we are putting console.error as fail to send notification email. Else if there is no email error, then we are sending a response of 200 with a message action performed successfully. Okay, so in step 6, we are sending response back to the user browser. So this is the whole chain of methods or steps that we are executing here, and which are async in nature. Therefore all of them have handler functions. Okay, so this is a callback sequence. Here we are only executing 5 steps, right? But there might be cases where we have to execute multiple steps. So we'll have callback inside callback inside callback. Okay, till infinity. Therefore, this can be a callback hell, correct? So if you want to debug, then you have to go through all the callbacks inside callbacks. Okay, as they have callback inside another callback. So you can see that the pyramid of doom has doomed us in this example. What happens if there are sockets involved in which a notification is sent in real time? The data to be sent via socket and stuff like that, all within one singular operation. Then the doom will keep on increasing, and it will be a living hell for developers to maintain the code, change business logic, and to debug it if any error occurs. So what's the solution for this callback hell or our pyramid of doom? Let's stay tuned for our next video to find the solution. Till then, happy coding!